Hey kids, this is Mr. Cozy, and this is video number 41, where we talk about combining functions together. Today we will look at composition. So let's get started. Okay, so a function is like a machine. So let's imagine that f of x is x plus 1. You want to think about this like it's a machine. So I have some x value that I put into the function, and then I turn a crank on the function, and out comes whatever y value matched the x value that I put in. So for instance, if f of x is x plus 1 and I put in a 5 into the function, I get back out of the function a 6, because this is how this particular function works. And if I have two functions, called g, I can put in an x into g and get back matching y value. Now, when we add, subtract, multiply, or divide functions, like if I want f plus g, all I do is choose some x value, put it in to both functions, receive whatever matching y value I get out of each of the functions, and add them up. Okay. Same thing for subtraction, multiplication, and division. Composition is a little different. If I compose two functions, let's suppose that I want to do g composed with f. What I'm doing is choosing some x value. I plug that into f. I take whatever matching y value that I get from f, and I hand that to g as an x value. And then g in turn does its thing. Okay, so when I compose two functions, what I'm really doing is chaining them together. I choose an x, plug it into the first function, take whatever y value that I got from it, and hand that to the other function as an x value. Okay, this is composition. So if I want to compose f with g, I would reverse this process. I would take some x value, let's say a 4, plug that into g, take whatever matching y value that I received from g and hand that to f as an x value. And then what I get out of f is my answer. Okay, this is composition. So let's look at a couple of examples. F of x is 2 minus x, g of x is 3x plus 1, and h of x is x to the second minus 1. So if I want to, in this case, if I want to compose f with g, I'm taking g and putting it into f as x. Okay? So what I will do is write out whatever f is, 2 minus, and instead of x, I'm going to put g. And then I can simplify this out. Okay, and so this is F composed with G. Another way of writing F composed with G is F of G of X. And if you write it this way, you have the sense of I am taking whatever is in G and putting it into F as X. Let's look at a few more examples. Let's look at G composed with H. Okay, so I am taking H and putting it into G as X. G is 3x plus 1. So I'm going to write 3, and instead of x, I'm going to write h of x squared minus 1 plus 1. And then I'll simplify it out. 3x squared minus 3 plus 1 is 3x squared minus 2. Okay? So in composition, I put one function into the other. If I do f composed with h, I write out f, which is 2 minus x, but instead of x, I write h. Okay? Now here's the thing about composition. Let's recall that f composed with g was negative 3x plus 1. If I compose g with f, if I reverse the order of the composition, then I am taking g, and instead of x, I'm going to put f into g as x. So I'm going to get 3 times 2 minus x plus 1. This is going to give me 6 minus 3x plus 1, or 7 minus 3x. Notice that the order of composition matters. Composition is not commutative. If I compose f with g, I get one answer. If I compose g with f, I get a different answer, because the order in which the functions act is important. Okay? Let's do one more example, and then I'll let you go. Let's compose h with g. Remember that g composed with h was 3x squared minus 2. If I compose h with g, then I'm taking h, which is x squared minus 1, and instead of x, I'm going to put in g, which is 3x plus 1. So I have 3x plus 1 squared minus 1. Now careful. I need to FOIL this. Gotta FOIL it. This is 3x minus 1, or plus 1, times 3x plus 1. It's going to give me 9x plus 6. I'm sorry, 9x squared plus 6x plus 1 minus 1, or 9x squared plus 6x. Okay? Once again, the order of composition matters, and guys, notice here that I had to FOIL. All right? Okay, I'm going to leave this here. Have a great day, and I'll talk to you guys later. Bye.